The electrical system in the USA utilizes several voltage levels, commonly 110/120 volts, 220/240 volts, and 440 volts. Firstly, 110/120 volts is the standard voltage for household appliances and lighting in most areas. Secondly, 220/240 volts is a higher voltage used for heavy appliances, such as air conditioners, stoves, and electric dryers. Thirdly, 440 volts is an industrial voltage used for machinery and other high-power applications. The electrical system is generally a split-phase system. This means it consists of two hot wires that carry voltage and one neutral wire which completes the circuit. The two hot wires are 180 degrees out of phase, creating a voltage difference of 240 volts between them. However, only 120 volts are available between each hot wire and the neutral wire. Voltage in the USA is not uniform across all states. Some areas, particularly in the Northeast, use 220/240 volts as the household standard, while most others use 110/120 volts. Becoming a self-employed electrician involves several steps. Requirements for becoming a self-employed electrician vary by state, but typically involve a combination of on-the-job training and classroom instruction. Many states require apprenticeships. These apprenticeships usually last 4 to 5 years and provide hands-on experience. Once the apprenticeship is completed, a licensing exam is needed to become a licensed electrician. After licensure, starting an electrical contracting business is possible. In more detail, the 120-volt system is predominantly used in residential settings for lighting, small appliances, and electronics. This voltage level is derived from the split-phase system, where the center-tapped neutral provides the 120 volts potential difference from either of the hot legs. This setup is ideal for safety and efficiency in powering everyday devices. The 240-volt system is essential for appliances that require a higher power draw to operate effectively. These typically include air conditioners, electric stoves, water heaters, and clothes dryers. Supplying these appliances with 240 volts allows them to operate more efficiently and draw less current compared to running them on 120 volts, which reduces the risk of overloading circuits. The 440-volt system, and sometimes even higher voltages like 480 volts, is primarily used in industrial and commercial settings to power heavy machinery, large HVAC systems, and other high-power equipment. The higher voltage reduces the current required to deliver the same amount of power, which allows for smaller gauge wiring and more efficient energy distribution over long distances. The split-phase electrical system is standard configuration in many North American homes. It is characterized by a 240-volt supply that is center-tapped to create two 120-volt supplies. This is achieved by having two hot wires, each carrying 120 volts with opposite polarity, and a neutral wire. The neutral wire is grounded, ensuring safety and providing a return path for current. The key benefit of this system is its ability to supply both 120 volts and 240 volts from a single electrical panel. A three-phase system is commonly used in commercial and industrial settings due to its efficiency in delivering large amounts of power. It consists of three alternating current sources that are out of phase with each other by 120 electrical degrees. This configuration provides a more consistent and smoother power delivery compared to a single-phase system. Three-phase systems are used to power heavy machinery, large motors, and high-demand equipment in factories, office buildings, and data centers. The grounding system is a critical safety component of any electrical installation. Its primary purpose is to provide a low impedance path for fault current to flow back to the source, which helps to quickly trip circuit breakers or fuses and prevent electrical shock hazards. Grounding involves connecting all non-current carrying metal parts of electrical equipment and appliances to a common grounding electrode, such as a ground rod or a metal water pipe. This ensures that any fault current will flow safely to ground, minimizing the risk of electric shock. The National Electrical Code (NEC) provides comprehensive guidelines and standards for the safe installation and maintenance of electrical systems in the USA. It is updated every 3 years to incorporate the latest technological advancements and safety practices. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. Local jurisdictions typically adopt the NEC as the basis for their electrical codes, with some modifications to suit local conditions and requirements. Overcurrent protection devices, such as circuit breakers and fuses, are essential for protecting electrical circuits and equipment from damage caused by excessive current flow. Circuit breakers are resettable devices that automatically interrupt the circuit when the current exceeds a predetermined level. Fuses, on the other hand, are one-time use devices that melt and break the circuit when the current exceeds their rating. Both devices are designed to prevent overheating and potential fires caused by short circuits, overloads, and ground faults. Wiring methods refer to the different types of cables and conduits used to safely route electrical conductors throughout a building. Common wiring methods include non-metallic sheath cable, often called NM cable or Romex, which is used in residential construction for branch circuits. Metallic conduit, such as electrical metallic tubing and or rigid metal conduit (RNC), is used in commercial and industrial settings for its durability and protection against physical damage. Each wiring method has specific requirements for installation, support, and protection, as outlined in the NEC. Electrical panels, also known as load centers or breaker boxes, serve as the central distribution point for electrical power within a building. They house the circuit breakers that protect individual circuits and provide a convenient means of disconnecting power for maintenance and repairs. The electrical panels are typically located in accessible areas, such as basements, garages, or utility rooms, and must be properly labeled to indicate the circuits they serve. Proper sizing and installation of electrical panels are crucial for ensuring the safe and reliable distribution of power throughout the building. Ground fault circuit interrupters, GFCIs, are life-saving devices designed to protect people from electric shock by monitoring the current balance between the hot and neutral conductors in a circuit. If a ground fault is detected, meaning current is leaking to ground through an unintended path, the GFCI quickly trips the circuit and cuts off power, typically within milliseconds. GFCIs are required in areas where electrical outlets are located near water sources, such as bathrooms, kitchens, and outdoor locations. Arc fault circuit interrupters of size are designed to detect and protect against dangerous arc faults, which are unintentional electrical discharges that can cause fires. Arc faults can occur due to damaged or deteriorated wiring, loose connections, or faulty appliances. A size monitor the electrical waveform and identify patterns indicative of arc faults, then quickly trip the circuit to prevent a fire from starting. The NEC requires F-size to be installed in many residential circuits, particularly in bedrooms and living areas. Electrical permits are required for most electrical installations, repairs, and alterations to ensure that the work is performed safely and in compliance with local electrical codes. Permits are typically obtained from the local building department or electrical inspector's office. Before starting any electrical work, it is essential to obtain the necessary permits and schedule inspections to verify that the installation meets all applicable requirements. Electrical inspections are conducted by qualified electrical inspectors to verify that electrical installations comply with the NEC and local electrical codes. Inspectors examine the wiring, grounding, overcurrent protection, and other aspects of the electrical system to ensure that it is safe and properly installed. Any deficiencies or violations must be corrected before the installation is approved. Passing an electrical inspection is essential for obtaining a certificate of occupancy and ensuring the safety of the building occupants. The process of becoming a licensed electrician typically involves several stages, including education and training, apprenticeship, and examination and licensing. Education and training provide the theoretical knowledge and technical skills needed to perform electrical work safely and effectively. This may involve attending a vocational school, technical college, or community college to complete a formal electrical training program. These programs typically cover topics such as electrical theory, wiring methods, blueprint reading, and safety practices. An apprenticeship provides hands-on experience and practical training under the supervision of a licensed electrician. Apprenticeships typically last for 4 to 5 years and involve a combination of on-the-job training and classroom instruction. During the apprenticeship, apprentices learn how to install, maintain, and repair electrical systems in various settings. Examination and licensing are the final steps in becoming a licensed electrician. After completing the required education, training, and apprenticeship, candidates must pass a licensing exam administered by the state or local licensing board. The exam typically covers a wide range of topics related to electrical theory, codes, and practices. Upon passing the exam, candidates are granted a license to practice as an electrician. Continuing education is often required for licensed electricians to stay up to date on the latest codes, technologies, and safety practices. Many states and local jurisdictions require electricians to complete continuing education courses periodically to renew their licenses. These courses help electricians maintain their skills and knowledge and ensure that they are providing safe and reliable electrical services. Safety is paramount in all aspects of electrical work. Electricians must follow strict safety procedures and use appropriate personal protective equipment, PPE, to minimize the risk of electric shock, burns, and other injuries. Common safety practices include energizing circuits before working on them, using insulated tools, wearing safety glasses and gloves, and following lockout/tagout procedures. Regular safety training and adherence to safety regulations are essential for preventing accidents and ensuring a safe working environment. Understanding electrical theory is essential for electricians to diagnose and repair electrical problems effectively. Electrical theory involves the study of fundamental concepts such as voltage, current, resistance, and power. Electricians must understand how these concepts relate to each other and how they affect the operation of electrical circuits and equipment. A solid understanding of electrical theory enables electricians to troubleshoot complex electrical problems and design safe and efficient electrical systems. Reading and interpreting blueprints is a critical skill for electricians. Blueprints are detailed drawings that show the layout of electrical systems in a building, including the location of outlets, switches, lighting fixtures, and other electrical components. Electricians must be able to read and understand blueprints to accurately install and maintain electrical systems according to the design specifications. Knowledge of the NEC is essential for all electricians. The NEC provides comprehensive guidelines and standards for the safe installation and maintenance of electrical systems. Electricians must be familiar with the NEC and adhere to its requirements to ensure that their work is safe and compliant with local electrical codes. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. Troubleshooting electrical problems requires a systematic approach and a thorough understanding of electrical systems. Electricians use various tools and techniques to diagnose electrical problems, such as multimeters, circuit tracers, and visual inspections. The troubleshooting process typically involves identifying the symptoms of the problem, gathering information, testing components, and isolating the cause of the problem. Once the cause is identified, the electrician can then make the necessary repairs to restore the system to proper operation. Maintaining electrical systems is essential for ensuring their safe and reliable operation. Regular maintenance activities include inspecting wiring, tightening connections, testing overcurrent protection devices, and cleaning equipment. Proper maintenance can help prevent electrical problems from occurring and extend the lifespan of electrical systems. It's also important to be familiar with common electrical tools. Electricians use a variety of specialized tools to perform their work safely and efficiently. These tools include wire strippers, pliers, screwdrivers, multimeters, conduit benders, and cable cutters. Electricians must be proficient in the use of these tools and maintain them in good working condition to ensure accurate and safe results. When working with electricity, it is important to always de-energize circuits before beginning any work. This involves turning off the circuit breaker or removing the fuse that supplies power to the circuit. Before working on an energized circuit, it is essential to verify that the power is off using a voltage tester. This ensures that the circuit is safe to work on and reduces the risk of electric shock. Grounding is a critical safety measure that helps protect people from electric shock. Grounding involves connecting all non-current carrying metal parts of electrical equipment and appliances to a common grounding electrode, such as a ground rod or a metal water pipe. This provides a low resistance path for fault current to flow back to the source, which helps to quickly trip circuit breakers or fuses and prevent electric shock hazards. Overcurrent protection devices, such as circuit breakers and fuses, are essential for protecting electrical circuits and equipment from damage caused by excessive current flow. These devices are designed to interrupt the circuit automatically when the current exceeds a predetermined level, preventing overheating and potential fires. It is important to select the correct size and type of overcurrent protection device for each circuit to ensure proper protection. Wiring methods refer to the different types of cables and conduits used to safely route electrical conductors throughout a building. Common wiring methods include non-metallic sheet cable, metallic conduit, and armored cable. Each wiring method has specific requirements for installation, support, and protection as outlined in the NEC. It is important to select the appropriate wiring method for each application to ensure the safety and reliability of the electrical system. Electrical boxes are used to enclose and protect electrical connections such as outlets, switches, and splices. They are typically made of metal or plastic and come in various sizes and shapes to accommodate different wiring configurations. Electrical boxes must be properly installed and secured to provide adequate protection for the electrical connections. Understanding the different types of electrical circuits is essential for electricians. Common types of circuits include branch circuits, which supply power to individual outlets and lighting fixtures, and feeder circuits, which supply power to multiple branch circuits. Each type of circuit has specific requirements for wiring, overcurrent protection, and grounding. It is important to understand the characteristics of each type of circuit to ensure proper installation and operation. Electrical outlets, also known as receptacles, provide a convenient means of connecting electrical devices to the power supply. Outlets come in various types, including standard 120 volt outlets, 240 volt outlets, and GFCI outlets. It is important to select the appropriate type of outlet for each application and install it according to the NEC requirements. Electrical switches are used to control the flow of electricity to lighting fixtures and other electrical devices. Switches come in various types, including single-pole switches, three-way switches, and dimmer switches. It is important to select the appropriate type of switch for each application and install it according to the NEC requirements. Lighting fixtures provide illumination for homes, businesses, and other buildings. Lighting fixtures come in various types, including incandescent lights, fluorescent lights, LED lights, and high-intensity discharge head lights. It is important to select the appropriate type of lighting fixture for each application and install it according to the NEC requirements. Electric motors are used to power a wide range of equipment, including pumps, fans, and machinery. Electric motors come in various types, including single-phase motors and three-phase motors. It is important to understand the characteristics of each type of motor to ensure proper installation and operation. Transformers are used to step up or step down voltage levels in electrical systems. Transformers are essential for transmitting power over long distances and for supplying power to equipment that requires different voltage levels. It is important to select the appropriate type of transformer for each application and install it according to the NEC requirements. Generators are used to provide backup power during power outages. Generators come in various types, including portable generators and standby generators. It is important to select the appropriate type of generator for each application and install it according to the NEC requirements. Renewable energy systems, such as solar panels and wind turbines, are becoming increasingly popular as a source of clean and sustainable energy. These systems generate electricity from renewable resources and can be used to power homes, businesses, and other buildings. It is important to understand the principles of renewable energy and the requirements for installing renewable energy systems. Smart home technology is becoming increasingly popular, allowing homeowners to control lighting, appliances, and other devices remotely using smartphones or other devices. Smart home technology can improve energy efficiency, enhance security, and provide greater convenience. Electricians play a key role in installing and maintaining smart home systems. Energy efficiency is becoming increasingly important as homeowners and businesses seek to reduce their energy consumption and save money. Electricians can help improve energy efficiency by installing energy-efficient lighting appliances and HVAC systems. They can also perform energy audits to identify areas where energy can be saved. As an electrician, it's important to stay up to date on the latest technologies, codes, and safety practices. This involves attending continuing education courses, reading trade publications, and participating in industry events. By staying informed, electricians can provide the best possible service to their customers and ensure that their work is safe and compliant with all applicable requirements. When estimating the cost of electrical work, it is important to consider all of the factors involved, including the cost of materials, labor, permits, and other expenses. It is also important to factor in the time required to complete the job and the potential for unexpected problems. By carefully estimating the cost of electrical work, electricians can provide accurate bids to their customers and ensure that they are making a profit. When managing an electrical contracting business, it is important to have a solid business plan, a strong team, and a commitment to customer service. It is also important to manage finances effectively, market the business effectively, and comply with all applicable regulations. By following these principles, electrical contractors can build successful and sustainable businesses. Electrical safety is a shared responsibility. Homeowners and businesses can help prevent electrical accidents by following basic safety precautions, such as avoiding overloading circuits, keeping electrical cords in good condition, and never touching electrical equipment with wet hands. By working together, electricians, homeowners, and businesses can create a safer environment for everyone.